We're going to talk today about the division properties of exponents. The first property is the quotient of powers property. Quotient means division. What do you do when you divide powers? Well, the first thing you have to do is make sure that they have the same base. As long as they have the same base, then you simply subtract the exponents. So, for instance, x to the 6th power divided by x to the 2nd power gives you x to the 6 minus 2, which is x to the 4th. Now, let me show you why this works. X to the 6th is 6 x's multiplied together. X squared is 2 x's multiplied together. These cancel out, these cancel out. So basically you're taking whatever's on the bottom, taking that away from the top, and you're left with x to the 4th. The second one is the powers of quotient properties. So what happens when you apply powers to a division problem? It's really very easy. The exponent on the outside goes to each part of the division problem. It goes to the top, which is the numerator of the fraction. It goes to the bottom, which is the denominator of the fraction. So when you have a positive exponent, you simply take the exponent and give it to each one of those pieces. If the exponent is negative, then it does two jobs. The negative part of the exponent remembers that you do the reciprocal. So what I do is I just go ahead and take whatever's inside here and flip it over. That gives me the reciprocal. Now the negative part has done its job. And then I take the m and apply it to the top and the bottom. Okay? And there you've got it. All right? Now let's try some. You need to pause the video so that you can do these problems. For the first one, you just subtract the exponents. That's going to give you 5 to the 2nd power, which is 25. For the next one, we need to remember that the rule applies if the bases are the same. These two have a base that are the same. So 2 to the 2nd divided by 2 to the 9th, if you subtract the exponents, gives you 2 to the negative 7th, which is in reality 1 over 2 to the 7th. Now, this should kind of make sense to you. If there's 2 2's on the top and 9 2's on the bottom, the 2 2's on the top cancel out, and the 7 2's that you have left are on the bottom. Okay? Then we're going to take this part, and that's going to give me 3 to the 4th divided by 3 to the 5th, which again is 3 to the negative 1, which is 1 over 3. And then the 4 to the 4th stays the same. So we have 4 to the 4th on the top, and then a 2 to the 7th, 3 to the 5th on the bottom, and you can use your calculator to work that out. All right? So erase these and move to this next problem. Here, 15 divided by 5, we do like we always have. 15 divided by 5 is 3. And then x to the 6th divided by x to the 6th. This is a great opportunity for us. Ready? X to the 6th divided by x to the 6th. Anything divided by itself is 1, correct? Is equal to 1. But we also know if we subtract the exponent, 6 minus 6 is 0. So that proves another property that we talked about earlier, the 0 property exponent. Okay? So, and this is a 1, so this is just a 3. Okay, let's go to the next one here. A to the 5th divided by a to the 3rd is a squared. B to the 6th divided by b to the 7th is b to the negative 1, which is 1 over b. Here you have a couple of options. I personally would maybe simplify this on the inside first. Let this x on the bottom divide into the x squared on the top, and that would make that x over y cubed, and then take that to the 3rd power. This exponent on the outside goes to the top and the bottom. So on the top, that's going to be x cubed. And on the bottom, we're applying it to something that already has an exponent. That's the powers of powers property. That's going to give me y to the 9th. Now, if you don't see that, and you take the 3 and apply it to all of this, it would go to this one, become x to the 6th. It would go here to make that one x to the 3rd, and here to make that y to the 9th. When you have x to the 6th on the top and an x to the 3rd on the bottom, that also is going to give you an x to the 3rd. So you have two ways to do that one. Okay? They're starting to get a little more complex, throwing a lot of little properties in there. Here I have parentheses, parentheses, exponents inside the parentheses. So start from the inside and work out. A cubed b taken to the 2nd power is a to the 6th b squared. Now I have an a cubed on top. I probably would go ahead and simplify this. A cubed divided by a to the 6th is going to give me an a cubed on the bottom. That just makes that a 1 on the top. And then that whole thing was squared. So 1 squared is 1. A cubed squared, remember you multiply the exponents together, gives me a to the 6th. And b squared squared is b to the 4th. Okay? Let's go down here. The negative part of this means reciprocal, so flip this over and make that y cubed over 2x. Now it's to the 4th power. So on the top, that's going to give me y to the 12th. On the bottom, 2 to the 4th power is 16, and x to the 4th power is x to the 4th. Okay, lots of opportunities for errors, so take your time. Okay, a negative exponent here means flip this, make this 3 over 2 to the 1st power. A negative exponent here means to flip this, make it 2b over 3a, and now it's to the 2nd power. So this is 2 to the 2nd power, which is 4, b to the 2nd power, which is b squared, 3 to the 2nd power, which is 9, and a to the 2nd power, which is a squared. And then that's multiplied by a 3 over 2. I can cross cancel. 2 will go into 2 one time. It'll go into 4 2 times. 3 will go into 3 one time. It'll go into 9 3 times. 1 times 2 is 2b squared on the top. 1 times 3 is 3, 3a squared on the bottom. And that's it.